everyone. Today we're going to learn about implicit differentiation. Now, usually functions which we are differentiating are written in the form of y is equal to something in terms of x's. And this we can differentiate through our usual methods. Here, y is explicitly defined in terms of x. However, that is not always the case. Consider the function x squared plus y is equal to 3. Here we can see that y is not explicitly defined in terms of x's. But in this case, we can also easily make that happen. By subtracting x squared on both the sides, we can write y is equal to 3 minus x squared, and we can differentiate this very easily. However, not all the time can we do what we just did here. Sometimes it would be very difficult or impossible to bring y alone. For example, sine of y plus y squared is equal to x cubed. Here you can see that we cannot isolate y on one side very easily. However, we can still take the derivative of this function by using implicit differentiation. Before we understand implicit differentiation, though, let us first look at the chain rule. Now recall that the chain rule states that if we have a composite function, f of g of x, the derivative of this function is equal to the differentiation of the outer function with respect to the inner function times the derivative of the inner function. Now, let us take y is equal to g of x. Substituting, we can rewrite the derivative as d by dx of f of y is equal to f dash of y times the derivative of y. Here, notice that you can easily isolate y dash on one side to find dy by dx. To better understand this, let us take an example. Here we have sine of y plus y squared is equal to x cubed. Now, we can take the derivative of this by applying the derivative to each of these terms. So we need to find the derivative of sine of y plus the derivative of y squared is equal to the derivative of x cubed. The right-hand side is very easy to evaluate. It is just 3x squared. For the left-hand side, let us start with sine of y. Using this rule, the derivative of sine of y is going to be cos of y times dy by dx. And here, the derivative of y squared is going to be 2y times dy by dx. Now, let us take dy by dx common in this equation. And now, to solve for dy by dx, we can divide by cos of y plus 2y to get our final answer as dy by dx is equal to 3x squared divided by cos of y plus 2y. Notice that over here, there are y terms in the derivative, but the thing is, for functions which are defined implicitly, like the one here, this is very common.